Look at the sheer scale of this operation. Commercial hydroponics is built for high-output production, capable of growing food at a faster rate than soil while using as little as 20 liters of water per kilogram of lettuce produced. But bringing this technology into a home setting is often intimidating. These active systems require a precise web of nutrient timing, circulating water lines, humming air stones, and an uninterrupted power supply. This creates a constant risk known as the oxygen paradox. Plant roots require oxygen to survive. If the power grid goes down and the water becomes stagnant, the roots will rapidly rot and the plants will drown. While these facilities are highly efficient, their reliance on complex machinery makes them inaccessible for off-grid living or anyone looking for a low-maintenance garden in a small apartment. This is where Dr. Bernard Kratky from the University of Hawaii changed the approach. He developed a passive hydroponic system that functions with no moving parts and no electricity. The setup is minimal. You take an opaque container, fill it to the 100% mark with nutrient water, and suspend a seedling so its roots just barely touch the surface. By the established rules of botany, this stagnant water should cause the plant to fail. Without constant aeration or water movement, the roots should rot and the plant should die within days. Yet in this system, it thrives. The Kratky method bypasses the standard rules of agricultural engineering. It proves that a plant can grow to maturity in a completely static environment, provided the system is set up correctly at the start. As the plant grows, it consumes water, causing the liquid to drop and revealing an expanding gap of humid air. Upper roots transform into fuzzy air roots, pulling oxygen from the atmosphere. Simultaneously, lower submerged roots continue absorbing liquid and minerals. The plant engineers its own survival mechanism. It uses the falling water line to create a custom, oxygen-rich microclimate, replacing the need for an electric air pump. To manage the water quality, we measure electrical conductivity, or EC. This tells us the exact concentration of mineral salts currently dissolved in the water. As the water level drops toward 25%, the chemistry of the reservoir changes. Because the plant consumes water faster than it extracts minerals, the EC concentration naturally and sharply spikes. This spike is why Kratky setups must start with a leaner nutrient mix than active systems. If the initial concentration is too high, the final spike will result in toxic salt buildup that burns the submerged roots. Passive hydroponics isn't just about stagnant water. It requires calibrating the initial chemical input to match the physics of a shrinking reservoir. There are two primary ways to disrupt this balance. First, using a clear container allows light to trigger algae blooms. These algae will quickly consume the dissolved oxygen, robbing the roots of what they need to survive. The second is the refilling suffocation trap. If you see the water getting low and refill the container back to the top, you instantly submerge the air roots. Without access to the air gap, the plant will drown. The only maintenance required for the Kratky method is the discipline to do nothing and let the system run its course. At the end of the growth cycle, the biology of the plant and the physics of the container align. The water level hits absolute zero, just as the plant reaches its maximum size and harvest maturity. This timing makes the Kratky method ideal for fast-growing, short-cycle crops like lettuce, spinach, and basil. By the time the water is gone, the crop is ready for the kitchen. Because the falling water line functions as a natural countdown, there is no need for harvest schedules, top-offs, or flushing the reservoir. Contrast this with the humming, power-dependent commercial hydroponic arrays. A Kratky container is silent, static, and operates without any external monitoring. It is a lesson in engineering elegance. Instead of using brute force machinery to manage oxygen and nutrients, it uses the plant's own ability to adapt to its environment. Starting a setup like this is as simple as finding a foil-wrapped jar, some tap water, and a single seed. Agricultural innovation doesn't always require more complex technology. Sometimes it means understanding nature well enough to remove the machinery entirely.